friends, I am Vaibhav Srivastava from Vaibhav E-Learning Academy, and today we are going to start a new topic in mathematics, that is calculus. And this is going to be a broader thought process, and in today's part 1 we will be discussing about the story. So let us start. We in this session or in this whole series of functions or calculations or calculus will be learning about the different functions of calculus and will be trying to solve them. We'll learn what are the applications, we will learn how to solve them, and we will start everything from the scratch. So let us start with the topic. Let us think about the topic calculus. What does calculus mean? If you ask me the question what does a calculus mean, I would say calculus is nothing but a branch of mathematics. Calculus is nothing but a branch of mathematics. Now, a fact about mathematics. Mathematics or math is considered as the language of the universe. It means that every phenomenon happening in the universe, the rotation of the earth, the revolution of the earth, the revolution of the Milky Way galaxy, or the revolution of the solar system around the Milky Way galaxy, or anything which you see in your everyday life, like the car motion, or the motion of planets, or the motion of anything, or any visible changes or any visible phenomenon can be expressed in the term of mathematics. So mathematics is said to be the language of the universe. Every phenomenon can be described. It is already present, but you have to define it using mathematics. So this is the beauty of mathematics. Coming to the branches of mathematics, we have many branches such as algebra, where we deal with variables, where we deal with the relations between the variables. Then we have geometry. Geometry is where we deal with the shapes or the polygons, the quadrilaterals and the different kinds of shapes, 2Ds and 3Ds. Then we have something very related to geometry, mensuration. Mensuration is a topic which is used to calculate the relations between the shapes in case of perimeters, in case of areas, the case of surface areas, circular surface area, lateral surface area, and etc. Then comes the topic of statistics. Statistics is the branch of mathematics which deals with data, the finding out the mean of the data, finding out the median, finding out the mode. Then we have trigonometry, which deals with the angles between of a right angle triangle. Then there is a branch of probability. This branch of mathematics deals with the chances, or what are the chances of something happening. And then we have something called as the calculus. Now the question is, what does this topic deal with? So before moving on to what this topic actually deals with, let us go to the history of from where we get the term of derivation or the term calculus, or how do we derive the term calculus. Starting off the name calculus. It is originally a Latin word which means, guess what the word calculus means in Latin? It means small pebbles. Small pebbles. Now the question is, what does small pebble have to do with mathematics or a branch of mathematics? Now the branch of mathematics or the story of mathematics was created during the 1600s time, when the technology or when the mathematics wasn't very strong enough. So people used to perform simple arithmetic functions just by using some objects. They used sticks, they used some rocks, and the most commonly used ones were the small pebbles. Reason, they were more frequent or they were more available, and second, they were lightweight, compact. Third, they could be stacked on each other. So small pebbles or little pebbles were used in mathematics for calculating something. Now, as you have heard the term calculate, or the term of calculator. All these terms are derived from the concept of calculus, which means small pebbles. Okay. Now, calculus, as we said, it is a Latin word. It means small pebbles, and it is presently used in a very large scale to identify a lot of things or to study a lot of things. Now we have been discussing about what the branches of mathematics are. We have been discussing about where calculus came from, the origin, but we haven't answered the question yet. The question is, what is calculus? What is the study of calculus? To understand the study of calculus, we have to understand one quote, and the quote is that the only static is the change. This quote is very important to understand the field of the calculus. The quote is that the only static is change. It means that static, what does static means? Static means stationary, still, not moving, with reference to something, but static is actually still at one point. But the only static thing is the change. Now it is irony, it is controversial, both are paradox to each other. The thing is, if you observe your surrounding, you see every time something changes, everything changes actually. What changes? For example, the time. The time around us changes. The air pressure. The air pressure around us changes. The wind speed, suppose. The wind speed around us changes. Okay, what if you decide not to do anything, just sit in a room, just existing, doing nothing? Then also there is one thing changing, and that is the position of the earth. There is the concept of rotation and revolution, which is continuously going on. So the thing is, the only static is the change. It means that every fraction of second there is some change going on. And calculus is the mathematics to study change. Calculus is the branch of mathematics which describes the changes, which is used to study the changes. It is used to write the changes which we see in a form which can be written on a paper. For example, we see the earth moving. We can try to write that equation in the form of an equation, in the form of a statement, by the help of the calculus. This was what the calculus is about and what are the uses of calculus. Now, this is going to be a very interesting part now, the story of calculus. What is the origin of calculus? Who made calculus and what is the idea behind calculus? To understand the idea behind calculus, we need to know about a very popular and famous scientist. And the scientist is none other than Galileo. Galileo Galilei. So he was a scientist or a person with a very big mind or with a great mind. He is today known for many of his laws of planetary motions. He is known for his inertial law, the law of inertia, and he is also known for some contribution in the topic of gravitation. One of the major contribution is doing an experiment. Galileo, a story goes on, I'm not sure if it is true or not, but the story or a statement goes on that Galileo once went to the Leaning Tower of Pisa and there he dropped two items. Now let us take the two items to be a coin and a note, currency note. So Galileo drops the coin and a note from the same height. Now let us try to interpret what is going to happen. According to us, the coin will fall much faster. It will reach the ground first, whereas the paper will swing here and there and then finally reach the ground. It will reach the ground much later. Now Galileo, what he wanted to say is that both of these objects fall with same gravitational force or same acceleration. He said that both of these objects will fall with the same acceleration. It may be either a coin or it may be a small 1 gram of rock or a 10 kilograms of iron block. Both of them will fall with the same acceleration. Now obviously at that time no one would have believed him because they are seeing the reality as something else. They are seeing that the coin reaches the ground first. But then scientists later tried to recreate the scenario where he was saying that you fall with same acceleration. For example, you create an environment without gravity, vacuum. If you create a vacuum and you try to drop one very light mass and a very heavy mass, both will reach the ground at the same time. And why? Because there is no air drag. What was the reason that the paper currency was going to the ground slowly? Because there was more surface area, whereas more drag force was applying, the air resistance force. Now if you make a vacuum, there is no atmosphere, there is no air resistance force, then both of the objects will fall with the same acceleration. This was the contribution of Galileo in the field of gravitation. Of course, he did many more contributions, but this is what we are going to discuss right now. Now, legend has it that Galileo, then he was dead after that, and the reason of death was he raised a question against the moral beliefs or the royal beliefs. The royals believe that the earth is centered and the sun rotates around or revolves around the earth, but then he gave another idea that it is wrong. The sun is in the center and all the planets revolve around the sun, which offended the royalties, and they then persecuted him and then they killed him. Now comes our second scientist over here, that is Sir Isaac Newton. Sir Isaac Newton. Now there is a very major and interesting coincidence that the year when Galileo died was the year when Newton was born. So many physicists consider this as a coincidence, or many of them believe this as a rebirth of Galileo to complete the concept. Now we all know the story of the apple and Newton, that there was an apple tree and Newton was sitting under it, reading something or reading a book or just sitting idly, when an apple from the tree falls on him. This was the story, and then he created gravitation. But actually there is another deeper fact inside. The thing is, Sir Isaac Newton was a very great follower and a very big fan of Galileo. Galileo had influenced him a lot, and he used to read his publications because all these experiments Galileo published it during his times. So Sir Isaac Newton used to study his experimentation, and Galileo gave the idea that there is something which pulls everything towards the earth. So while when the apple fell on him, then he used to think about it. He took the apple, he threw it to the atmosphere, he threw it to the above the ground again. He sees that the apple again falls back to the earth. He took another rock, he tried to throw it up, it comes back to the earth. Now he was getting a little bit interesting, noticing how all the objects are coming towards the earth. Then during the evening time, when he was still thinking about all this, he noticed another thing, that is the moon. Now the question which arises in his mind was, if the earth's force is able to pull a small apple, why is it not able to pull a large moon? Now this is the concept of gravitation. Let us write down the formula of gravitation which we know. The formula of gravitation is G m1 m2 by r square. From this, what relation can be derived? We can say that force is inversely proportional to the square of radius. It means as you increase the radius in the squares, the force of gravitation also decreases because it is inversely proportional. So according to this, the moon is very far away. Indeed, the mass of moon is large, but the radius of the moon is the distance between the earth and the moon is much larger than the mass. So the mass gets neglected and the force of gravitation nullifies. So that is why there is a force of gravitation due to which it is just rotating around the earth, revolving around the earth. Now, Sir Isaac Newton found this very interesting, why the moon does not fall towards the earth. Now, Isaac Newton wanted to find out the relation between the force. He had to find out what is the relation between force and the mass. He wanted to find out what is the relation between force and distance, r suppose. Is it inversely proportional, directly proportional, whatever? He wanted to find out the relation between them. Now, from this era begins the era of experimentation. He started to experiment using different values. He took two different masses, or he assumed the mass of the earth, a mass of the 1 kilograms of ball or 1 kilograms of an object, and then he knew the distance. He tried to find out the gravitational force. It took a very long time to experimentation and to find out the values. he came to a conclusion that force is directly proportional to the mass and force is inversely proportional to the distance square. How? Because if you increase the mass, the force of gravitation increases. If you increase the distance, the force of gravitation decreases. The thing is, Isaac Newton discovered this thing when he was 23 years old. So if he discovered this thing, he must have given the formula when he was 23 years old. No, this formula came when he was 44 years old. There is an approximate gap of 22 years, which many people approximate to be 25 years or 30 years, but there is a gap of 22 years. The question is, what was Newton doing these 22 years? It is not like he was finding the value of the G. No. The thing is, Sir Isaac Newton wanted to give this experimentation, give this phenomenon to the world. But the scientists or the physicists during that time, they will not accept it just as it is, because Sir Isaac Newton cannot go to everyone saying that here are two balls, here is the value of force, here is the value of gravitation, here is the value of distance, this is the gravitation force. This kind of law isn't accepted. You need a proof for everything. So Sir Isaac Newton had to get to this formula, and for that he had to find the maths, how to do it. He was unable to do the mathematics for a very long time. Then what he did was, he took his time and he created his own branch of mathematics. He created calculus. He took 22 to 25 years to create another separate branch of mathematics called as calculus, and using calculus he was able to express his formula of gravitation, which gave us to the legendary formula F is equals to G m1 m2 by r square. This was the story of the gravitation, or this was the story of how did we get to the topic of calculus, who invented the calculus. So it is said to be Isaac Newton. But there is a small catch over here. A very small but a very interesting catch over here. If you look up to the internet for the story of calculus, who created calculus, you will find majority answer to be Sir Isaac Newton. But there is another scientist whose name is hidden in the beneath list of big scientists, and that scientist is Gottfried Wilhelm Leibniz. Now, if you try to look up towards the history of the calculus, if you try to look up towards the story of calculus, you will find out that many scientists or many physicists believed that Sir Isaac Newton and Leibniz, these both people are actually very separate people. Sir Isaac Newton was from the United Kingdoms, Leibniz was from Germany. It is believed that they both wanted to create a mathematics to express their own individual laws, and they both created the calculus themselves, and both the calculus were exactly same. That is the theory which is given by many people, but that is obviously not that true, because calculus is a very vast branch of mathematics, and a very vast branch of mathematics being given by two different persons at different place at the same time is not possible. Then the question is, why do people think of Leibniz and Newton both at the same time while thinking about calculus? See, the main thing which is required for calculus is how you are trying to approach it. When they both were trying to figure out the relations to their formula, they were getting a problem in one value. The value is of limits. The thing is, if you want to get to an answer which is very close to the answer but not the exact answer, what is the meaning of this? Let us suppose there is an equation x square minus 4 by x minus 2. Now, here if you try to put the value of x is equals to 2, then the whole statement becomes invalid. The whole statement becomes not defined. Why? Because 2 minus 2 is 0. Anything divided by 0 is not defined. So, this is an undefined equation or undefined expression. Now, there was some similar expression where both Leibniz and Newton were trying to get out the closest value as possible. So they were trying to get the value of x such as 1.999 or something. But this was the problem which both were encountering at the same time. So both of them submitted their problems at the similar time. That is why people assume that Leibniz and Newton both have given the formula or the calculus mathematics at the same time. Now I have introduced a term over here, that is limits. What is limit? We'll discuss that in a moment. This was the idea of the confusion between Leibniz and Newton. Now coming to the final part of the video, calculus is actually a very vast branch of mathematics, but there are three main tools to deal with mathematics, to deal with calculus. Three tools or functions for calculus. The first tool is the limit function. The second tool is differential function. And the third tool is integral function. These three functions are widely used if you have to do any calculation in calculus. So now this was the video for today. Today we learned about a thought process of what an calculus is. We learned about how can you define a calculus. We learned about the history of calculus, the history of the name of calculus, and finally we have learned about the conflict between Leibniz and Newton and function. Now if you do not understand the conflict between Leibniz and Newton, don't worry, that will be continued in the limit function. That will be the next video. And according to our syllabus, we won't be dealing much with limit function. Our main focus is going to be on differential function and integral functions. So we will have a smaller, simpler video on limit the next time, where we'll be discussing what the limit is. So I hope you have enjoyed this video. Do comment if you like the video and share, and like and subscribe. Thank you so much. Goodbye.